Okay, so 7.1, exploring the characteristics of exponential functions. An exponential function has the form f of x equals a b to the x. The graph of an exponential function can have two different shapes as shown. All exponential functions in the form f of x, a times b to the x, where a is greater than 0 and b is greater than 0, and b is not equal to 1 have the following characteristics. Okay, grab your calculators, please. First graph that you are going to graph. Let's have a look at this. Change your window to minus 10, 10. Start with that. It's your standard window. And then I want you to clear all graphs. Make sure your stat plot is not on, so go y equals. And then 2 hat x. Hat x, graph it. Anybody graphed it? Yeah? Thank you. What do we see? Is that what you get for your graph?
Yeah.
It says invalid. Is that in?
Change your window.
I did.
You have a minus or a subtract as your 10.
Oh,
Next graph.
It still says it.
Okay.
Says what?
Figure out how to get out of that. What did I say? You have to take off. Stat plot. The very top. Your plot is on. Get it off. Hit enter. Okay, so these are things you got to fix on your own on the exam. No helping. Okay, so when you go through your regressions and you're using your stat plot, you got to turn it on, and when you're doing graphs like this, although there will be regression graphs for this section too, you got to shut it off. Okay, so you got to know when you need the stat plot on and when you have to shut it off. Only when you use regression graphs do you have your stat plot on. Do you understand that? That'll be something you need to write on your cheat sheet. Only when you have regression graphs do you use stat plot. Okay? All right, next graph. Graph that, please.
We get rid of the old graph.
Nope, leave it. And then graph this, please. What do you see? What do you notice about all those graphs?
They all like start in the same place.
Meaning what? You're right, but how do you explain that mathematically? Nope.
They all start on the same point on the graph.
Nope, they don't all start at the same point. No.
They all have the same y-intercept.
They do have all the y-intercepts. I agree with. Okay, so there's number one. What do you notice about it? Their y-intercepts are all equal to
1.
what is it? Well, get off your calculators for a second and use your brains. God forbid. What does it mean when you try and find the y-intercept? What does x have to equal?
0.
What's 2 to the 0, 3 to the 0, and 10 to the 0? 1. Your y-intercept is always 1. So if, in this form, now I don't have an a value in any of these questions yet. We'll worry about the a value in a second. But if a is greater than 0, greater than 1, it's going to be important. We'll talk about that in a second. And b is a whole number. Okay, so it's also a number greater than 1. Your y-intercept is this. Now, somebody said your starting point. It's not my starting point. We just learned about this in the last section. What do we describe this graph as? Okay, where it begins and where it ends. What's that called? The end behavior. And what's the end behavior for all these graphs? 2 to 1. That's important. Your end behavior is 2 to 1. Doesn't change. This stuff you have to mark down on your sheet. You've got to know these 4 things. Okay, because we're going to do we're going to do logarithmic graphs right away. And they're 4 are equivalent to this. End behavior is 2 to 1. What's the domain for this graph?
This is an element of all reals.
X is an element of all reals. What is the range for this graph?
Y is greater than 0.
Y is greater than 0. What is the asymptote, the equation of the asymptote for this graph? Don't remember what an asymptote is? Okay, good. An asymptote is a line in which the graph approaches but never touches. So it's an imaginary line. In this case, this is it here. So it's a line that the graph approaches but never touches. These, now I'll explain this to you in a second a little bit better, but the equation of that line is y equals 0. That's the equation of your asymptote. Now, here's what I want you to do. I want you to think about this for a second. Okay? When x is 0, what is y here?
1.
1. When x is 1, what is y? There you go. Let me do it this way. When x is 3, what is y in the red one? When x is 3, what is y?
16.
One too many. Dylan, pay attention. What is it?
1x is
When x is 3, so put a 3 in here. What's 2 to the power of 3?
Oh, 8.
Put a 2 in there. What is it? Put a 1 in there. What is it? 0?
1.
Negative 1. 2 to the negative 1. What is that? Remember your exponent rules. What do you do when you have a negative exponent?
Divide.
Sort of. 2 to the negative 1. What is that? If I wanted to change that to a positive exponent, how would I do that? No? No? This is grade 10 math. How do I make that exponent positive?
reciprocated.
Yeah. Except I'm not quite reciprocating, but you're right. Put a 1 over it. Becomes that. What's 1 over 2 to the 1? A half. When x is negative 2, what is it?
1/4.
Quarter. What?
8.
An eighth. And then what would be the next one?
16.
16th, and then
Mr. Evans,
132nd, then
64.
164th,
128.
128th, 256. What do you notice about that number?
Doubling.
No, it's not doubling.
Well, I mean,
Times.
What is it?
halves.
It halves, right? So I'm actually multiplying, I'm not dividing, I'm multiplying each one by a half, right? Essentially what's happening. But more importantly, what about the size of that number? What's happening? As this number gets smaller, what's happening to that guy?
Small.
Smaller and smaller and smaller. What number is it approaching?
0.
It's approaching 0. It's going to continue to get smaller and smaller and smaller, but never actually get to 0. Because no matter what value I put in here, there's no possible way I can go 2 to the x equals 0 and get a value that works. So that's what this asymptote is. It's a line in which your graph approaches it, but will never hit it. Okay? You'll learn a lot more about asymptotes in pre-calculus. But for now, this is what we need to know. And we need to know this because we're going to use it for logarithmic graphs as well. So, you notice that this gets smaller, right? And this gets larger. So now, these 4 behaviors right here, you have to remember those 4 behaviors. They are extremely important to you because when we do logarithmic graphs, your 4 behaviors for logarithmic are mirrors of this, but inverses of it. So we'll talk about that in a minute. Okay. Look at the example on page 178. Determine which of these 2 graphs represents an exponential function. If possible, identify the type of function. It's graph 1 or graph 2 an exponential function. Graph 2 is. What's graph 1?
Quadratic.
Quadratic function. Very good. For each function that is exponential, state the following. How many x-intercepts? We didn't talk about that. Let's go back to this for 1 second, please. How many x-intercepts are in this graph? 0. Doesn't cross the axis. Can't touch 0. Right? 2 to the x cannot equal 0. So there's no x-intercepts, right? Okay? So what is the y-intercept in this graph?
5.
The y-intercept is 5, so when x is 0, y is 5. Dylan? What's the end behavior, Dylan? Yes, you do. Where does the graph start on the left? What quadrant? This means that things didn't go well in the last test. You don't know what the end behavior is. What's the end behavior on this graph? 2 to 1.
Oh,
Graph starts in quadrant 2 and ends in.
okay.
What's the domain of this graph?
X is an element of all reals.
X is an element of all reals. What's the range in this graph?
Y equals 0.
Y is greater than 0. All of these hit. Okay? Why is the y-intercept equal to 1?
There'd be a value.
There'd be an a value. Very good. Very good. There's an a value. What's the a value?
5.
5. Because all of these graphs go through 1, correct? So then how do I get a graph that doesn't go through 1? I have to multiply by a value in front, an a value. So if it's going through 5, then that a value has to be 5. So this graph that you have on your paper right now quite possibly could be this. I don't know what this value is here. This I don't know. But I do know that this guy is that.
So your a value is your y-intercept.
Your a value, no, not quite. It may be in each of your cases. I don't know if we do transformations yet. I have to wait and see. I can't answer that because I could have this.
Oh,
Right? So that's going to affect my y-intercept as well, if I have a value out here. So I don't know if we do that in this class. I don't think we do, but anyways. Okay. The biggest thing is you need to know those 4 things. You need to know those 4 characteristics.
Do we need to do the x-intercept then too, or just when we talk about these characteristics?
The x-intercept
Should be mentioned. So,
does not exist. It does if you have the graph move up or down. Otherwise, it doesn't exist. That's the only way you can have it. Okay? All right. So let's look at 7.2. 7.1 is just if you look at your practice questions, you can graph those and you can get your values. I didn't talk about this. What happens? So let's take a look at this now. What happens to that graph? Y equals 1/4 x. Without graphing it yet on your calculator, somebody tell me what it's going to look like and what changes are made from my original graph.
It's gonna be decreasing.
It's going to be what?
Decreasing.
Decreasing. Nice work. Okay, so what's my end behavior? Two to one. Okay. All right. What's my y-intercept?
Quarter. Oh, no, 1.
What is it?
1.
How come? How do I find my y-intercept?
You put 0 in for x and anything to the exponent of 0 is 1.
So my y-intercept is still the same, isn't it? Yeah? So, decreasing. Is that what we suspect it looks like? Decreasing value and behavior, 2 to 1 still, right? Okay? So let's do this quickly without calculator again. Even though you're going to use a calculator all the time. Let's do it quickly. I put 1 in for x. What do I get?
0.25.
Pardon me?
0.25.
0.25. A quarter, right? I put 2 in for x. What do I get?
0.125. No.
No.
Okay.
Using fractions. No. I put 2 in for x. Is that a quarter times a quarter?
1/16.
Thank you. Right? I put a 3 in for x. What is that? Oh boy.
32. Oh. A 64.
What about 4?
128.
No?
1, 2,
Yeah,
56.
calculator.
1, 2, 56.
1, 2, 56. Yeah. Okay, so as I get larger out here, what's happening with my y values?
It's smaller.
They're getting smaller. So what have I created on this graph that we just learned about? That's called an asymptote. What's the equation of that asymptote?
Y equals 0.
Y equals 0. Remember that when you give the equation of any line, if it's a horizontal or vertical line, it'll be y equals or x equals, right? That's the equation of the line. So the equation of this line is y equals 0. So my y-intercept is still 1. It's a decreasing graph. My end behavior is still 2 to 1, right? Okay? It's still approaching my y equals 0, but doesn't hit it. All right? So my 4 characteristics are pretty much the exact same. Only difference is it's, a decreasing graph instead of an increasing graph. Okay? Let's look at the example on page 180. Excuse me. Allergic to work, clearly. That's good, because I always thought you guys were just allergic to me, but work will take. All right. Okay, so 7.2 is using your regression again. And take a look on, go second function, calculate, and find your exponential regression on your calculator, please. What number is it on there?
What is it?
exponential regression.
On
Sorry, my bad.
No,
I lied to you. My bad. Stat, calculate.
Okay.
Sorry, I said second function calculate. No.
It's just 0 is the number.
0 is the exponential one. Okay. Everybody found it? Stat,
Mhm.
calculate,
Mhm.
go down.
Yeah.
Exponential
It goes
regression.
further.
Oh,
Oh.
What do you do after you like?
Oh no, you do the same thing you did in the last section. Line 1, line 2, y1, y bars, right? Okay, don't worry about it right now because you don't have information in there yet. Right? So after you put your stat in your line 1 and your line 2, you do the same process that you did last section. So it's exponential regression, line 1, line 2, y1. Put your stat plot on and it'll give you your regression graph, okay? Everybody okay? They found regression? All right. Let's look at page 180. All right, without graphing, let's answer some questions. How many x-intercepts? 0 x-intercepts. Good. What's the domain?
X is not unknown.
What's the range? 1 is greater than 0. What's the y-intercept? Sure?
Yeah.
Anybody want to disagree with them? Come on, step up.
Probably because you're questioning
Okay, so how do I find my y-intercept? 0 here, right? What's this value to 0? 1. What's 1 times 8? All right, he's right again. Supposed to help me. Come on. Is this function increasing or decreasing? Decreasing. Why is it decreasing? This is the one we want to talk about. Why is it decreasing? No. Ah, yes, sort of. Yes, I don't, yeah, okay. Let's not look at it like that. You are absolutely correct. And you can think that way, and it's always right. Okay. What I was looking for, though, is the b value is between 0 and 1. Okay, the b value is between 0 and 1, meaning you have a fraction there. So that's why it decreases. But yes, you're absolutely right. The x value is negative, but it's hard to see that when I've got 2/3. If I had 1 over a value, then I would assume that that value on the bottom is 4 to the negative x. But when I have an actual fraction, is it actually a negative x or is it not? Right? Because of the the numerator on there not being 1. Okay? But yeah, you can think that way and you're not going to get it wrong. What's the end behavior?
2 to 1.
2 to 1. Okay?
So the end behavior is never going to change. It's always going to be 2 to 1.
And be 3 to 4.
Oh, but.
I'm going to check. I don't want to say yes, but I also don't want to say no. Okay. To me, I got to make sure of this. Okay. So I'm going to go with yes.
Why?
Alright.
It's kind of like.
I'll tell you why. The only way that this can end up not being, okay, so this is, right now, this is in this form. It's in that form right now. If it's in this form, as far as I'm looking at these questions, and I'll look at the exam questions, we have no horizontal or vertical shift. Okay? Which then means that it has to be 2 to 1. The end behavior has to be 2 to 1. The only way that this is not 2 to 1 is if I have a value out here. Usually I make that a D, because then it could move your graph up or down. So if this is a negative value, and let's say it moves it down, then my end behavior would be down here. It's not going to happen in this course, I don't think. I haven't seen it yet, and all the questions I've looked at, I don't see it yet. All right? But you do have your calculator for every single question. You can graph it, and then you should see it from there. You have this guy for the exam. My suggestion to you though is to get the iPads.
You can take the iPads into the
Yes, you
exam.
can. Provided no internet access.
That's what passed my last year.
Didn't you use a dropping calculator last year? Yeah.
No, I used them.
Okay, so you have to make sure, you'll have to check in the library. If you're using an iPad from the library or you're using your phone, you have to make sure that that app is usable without internet access. And I believe Desmos, you can upload or download it and then use it.
Good to go.
Okay, so you gotta do it without. But yes, and you're crazy not to use the iPads. Alright, it makes things,
So what's the difference between the two? Like, why is that?
on this one, number one,
It's easy to use.
you have to put it into y equals at all times. Okay, which shouldn't be the problem. Actually, I would use these for the regressions. I don't know how to use the iPad to get the regressions on there. There are easy ways to do it, I'm sure, but I like the regression on this calculator way better. So if I'm using regression graphs, I would use this all the time because it's very simple to do. You know how to do it. You've been doing it for 2 years now. How to get that regression. Well, 1 year for this, but for regression, but you use this calculator. Okay. For just seeing pictures of graphs that aren't in y equals form, the iPad works the best. Okay? You can use both. You can take them both in. But you have time then on your exam, so you don't want to be messing around. But for all the questions that use regression, I would use this guy. Okay? The thing about the iPad as well is it will give you your windows automatically.
Yeah.
Without you having to zoom in or zoom out
Or
or
just pinch,
change
make it bigger. Or
Yeah.
smaller. And it's easier to find like your points on the graph.
right. Yes, your coordinates are usually easier to find as well. Okay, so you can use both, and you should be starting with that before Christmas. If you're going to use the iPad, get a handle on it before Christmas. Okay, for today you'll just use the calculator, and we've got 7.1 and 7.2 to do. 7.3 is using your regression, but for right now 7.1 and 7.2. There's only 4 questions in 7.1, so there's less 3. Okay. Does everybody know how to graph this on your calculator? Just get your head up, man. Does everybody know how to graph this on your calculator? Do you know how to find your intercepts and all of that? Using calculate, right? Okay. All right. You got to finish 7.1 and 7.2, which is to the end of page 183.